Want to learn more about condition monitoring, or the CBM engineers looking for how to set the correct emissivity settings for your IR or thermography camera? So you have clicked the right video. So hello guys, welcome back to Skill Talk and in our thermography expert series. So today we will be focusing on one of the most important factor for accurate thermography, that is the emissivity. Because normally whenever we are going for thermography, so the most common and most basic issue that we have is, that what emissivity should I put in my camera settings so that I can have the perfect image. Okay, so now here in this video we will be learning that what emissivity is and how to measure it on site, and how to set in the camera, and most importantly that how to apply in the field. So let's start with our first section, that this section will be covering that why emissivity matters for a thermographer. So normally we know that our thermal camera doesn't measure the temperature directly, right, as we have discussed in our previous videos. So it detected IR and calculate the temperature based on the emissivity settings that we enter inside our camera. So if emissivity settings that we put in our camera is wrong, so definitely the output will be wrong, or you can say that your readings or your IR image will be inaccurate. So that's the reason that why thermographers must always check and adjust the emissivity, especially when scanning the different materials, because we know that all the materials are having the different emissivity or different properties. Let's say that if you are talking about our skin, or you can say the human skin, right? So the emissivity will be normally somewhere around 0.97, 0.98, and if you are just talking about the electrical tape, it will be somewhere around 0.95. Then it will be slightly lesser for painted steel, maybe somewhere around 0.9 and maybe 0.92. Then if you will talk for the concrete or some bricks, so it will be somewhere around 0.9 or maybe slightly below than that, maybe 0.88 or 0.89. And in the last, if we talk about the shiny surfaces, or you can say the polished surfaces, let's say polished stainless steel or polished aluminium, so the emissivity will be very, very low. It can be 0.2 or even far lesser than that. So overall the key point is this, that the painted surface are reliable, but the shiny material, it's hard to rely on the readings for that. Now, since we have discussed some reference values for the different kind of materials, what kind of emissivity they may have, but when we are going on generally on the field, so it's very hard to say, that what exact emissivity should I put there so that I can have the exact temperature of that particular material. So now we will be discussing that how we should measure this emissivity in the field. Okay, so let's take there are 2 or 3 ways that how we can practically do this thing on the field. The first way is that putting the electrical tape method. Okay, so what in this, that we will be taking one black tape, and this black tape we are going to put on the surface of which we are going to take the IR image. So since we know that the black tape emissivity is somewhere around 0.95 or 0.96, so what we will do, we'll put this tape on that object and we'll just wait for a few seconds or maybe few minutes, maybe 1 or 2 minutes or 3 minutes, so that that tape should attain the same temperature that material have. Okay, so till then what I will do, I will put emissivity in my camera to 0.95, which is the emissivity of that black tape. Now what happened, that after few minutes I will compare the readings on the tape that I am getting. Let's say on the tape I am getting the temperature of 100 degrees Celsius versus the surface or the object or the material that I want to take the IR image. So what I will do, on the basis of that reading, I will adjust the emissivity until the surface matches the temperature that I am getting on the tape. Okay, so that will be the real emissivity value for that particular object, or for that particular material. So this thing can be done in another way also, that is, you can say the second method, that is the by using the thermometer, the contact thermometer, or you can say the laser gun also. So what we can do in this case, that we will be measuring the true surface temperature using the maybe the laser gun or maybe the thermocouple probe. And what I will do, I will adjust my camera camera emissivity until I will not attain the same temperature that I am getting in the thermocouple probe, or you can say the laser gun. Okay, so there is another third method. If by chance you are not able to perform these two methods, so there is another third method, that is the we are having some calibration stickers or the paint dots, right? So you can use that. So you can just put those stickers on that material, and in the same way that we did for the black tape, in the same way you can continue to match the temperature of that sticker. And once you attain the same temperature that you are getting on that sticker, so that will be the emissivity of that particular material that you should use in your camera. So these are some methods which are very well reliable and should always be the part of our field practice. So I hope guys it is very much clear that how you should set the emissivity on field. So to make it more clear, let's discuss a real-time example. Let's take one real-time example. Okay, so let's say that we are inspecting a stainless steel pipe, and this pipe is carrying some hot material, or you can say the hot steam or hot gases. Okay, and let's say I have taken out my camera, and in my camera it's showing me the, let's say, the temperature of let's say 40 degrees Celsius or 50 degrees Celsius, let's say. So since we know that the gases that are carried by this pipe are hot, so definitely the temperature can't be so low, right? That is the 40 degree or 50 degree. So what I will do for my confirmation, I will apply one tape here. So what I will do, I will place a piece of a black electrical tape on this pipe, and after few minutes the tape reaches the same temperature as that of the pipe surface. So now what I will do, I will set my camera on the with the emissivity of 0.95, that I already know that it's the emissivity of a black tape. So then the tape readings will come out to be, let's say, 100 degree or maybe 120 degree or 130 degree or 150 degree, whatever it is. Okay, so that will be the true surface temperature of that pipe area, or you can say that material, right? So now what I will do, I will adjust this emissivity settings so that I can attain the same temperature on the pipe. So now what I will do, I will move this my camera to the next to the pipe. Okay, and I will slowly reduce the emissivity until I will not show I will not get the same temperature that I am getting on that electrical tape. So let's say I was getting the on the electrical tape I am getting the temperature of 100 degrees Celsius. So once I will slightly move the camera from that place, so I will continuously reduce the emissivity until I will not attain the same temperature of 100 degrees Celsius on that pipe. So let's say that now my emissivity setting is around 0.1 or 0.15, and I have attained the same temperature that I am getting on the black tape, right? So this is the emissivity that I will be actually using to scan this entire pipe. Okay, so without this correction, it will be very difficult for us to do the analysis or to do the scanning of that entire pipe, because you know that how much difference is there in the actual temperature, or you can say the false temperature. So initially I am getting the false temperature, that is the 40 degrees Celsius, and once I adjust my emissivity or you can say that I have put on the proper emissivity, so I have attained the temperature that is around 50 to 60 degrees Celsius higher than the I am getting before, right? So my initial temperature was 40 degrees Celsius, that was my false temperature, and my original temperature for that steel pipe, or you can say the shiny steel pipe, is 100 degrees Celsius or 120 degrees Celsius, right? So this is that's the difference between the wrong data, or you can say the real reliable diagnostics. So let's summarize this video. So what we learn in this video, that always we have to set the emissivity before recording the temperature data. Okay, and second, that how we can use the tape, stickers or the contact probes for the accuracy. Okay, and the third thing that we have learned here is that one emissivity value doesn't fit for all the surface, because all the material are having the different properties, so there may be slight difference of the emissivity. So, and the last thing that we have learned is this: the shining metals need the special attention. Why? Because always shiny material have the low emissivity. So I believe guys you have learned how to set the emissivity in the video, and I believe that you will never do any mistakes, right? So if you find this video helpful, and so please don't forget to like and subscribe.